Good morning. My name is Chris Mawata, and I want to introduce you to AI data governance. I have been a learning tree instructor since the year 2000 and have written more than 40 courses for Learning Tree. I've also worked as a professor of mathematics at the University of Tennessee at Chattanooga and published papers in mathematics, machine learning, and visualization. Today, we want to talk about governance in AI. So let's start by thinking about what artificial intelligence actually is. The term artificial intelligence, AI, has many definitions. Here is one of those definitions from the US government: a computerized system that exhibits behavior that is commonly thought of as requiring intelligence. So, what are the benefits of AI? Well, we have efficiency. AI can automate repetitive tasks, which frees up humans to focus on more creative work. Safety. AI can help create safer working environments by minimizing human error. Improve decision making. AI can analyze data and help us to make better decisions and give us better insights. Cost reduction. AI can improve analytics and resource utilization, which can lead to cost savings. Better customer service. AI can provide personalized customer opportunities, and it can lead to many new products and services. So, what about in government? What are the key applications of AI in government? Well, we have public welfare, AI-enabled food distribution systems. These optimize logistics and enable us to reach areas affected by natural disasters. Personalized healthcare systems powered by AI recommend specific treatments based on patient data, and so they improve outcomes. Security and compliance, things like facial recognition systems that monitor public spaces for security threats. We have machine learning algorithms that can scan financial transactions and help us to prevent money laundering and fraud. We also have operational efficiency, things like AI-driven traffic systems that dynamically adjust signals to reduce congestion in urban areas. We have predictive algorithms that forecast infrastructure maintenance needs and thus reduce operational costs. Here are some applications of AI. They include manufacturing robots, self-driving cars, smart assistants, social media monitoring, marketing chatbots, language translation, virtual travel booking agents, automated financial investing, healthcare management, image recognition, and others. So when it comes to data governance, what are the goals going to be? Well, for one thing, you want to ensure that your data is valid. So you'll be looking at data quality. You want your data accurate. You want it consistent, unbiased, and reliable. We shall be looking at data security. We'd like to ensure that data is protected from unauthorized access and use. Look at data availability. We want to make sure that when we need data, it is going to be accessible for business intelligence and data discovery. Then, of course, we want to make sure that we comply with various regulations. So we shall be looking at laws and regulations that come into play. And then the integrity of the data. We want to ensure that the data is resilient and that it is maintained and used responsibly. And of course, we want our data to be trustworthy. We want to make sure that uncertainty is eliminated and that the data allow us to be accountable, transparent. We want our models to be explainable, to be interpretable. Now, there are going to be challenges and risks. The key concerns are going to be privacy, ensuring that citizen data is protected amidst growing data sets; fairness, We want to avoid bias in algorithms, avoid systemic discrimination, I should say. Transparency, making AI decisions auditable and explainable. And of course, regulatory compliance. We want to balance rapid innovation with ethical constraints. Some mitigation strategies for these risks are going to be implementing robust AI governance frameworks and conducting third-party audits for AI algorithms. So the bias we worry about, where would it be coming from? Well, there are several sources of bias. For example, the bias could be coming from inside of our data. The data itself could have the bias baked in. It could be the algorithms that we're using to process the data. Algorithms can introduce bias by favoring certain outcomes or applying weights disproportionately to different predictor factors. It could be the way that we're measuring. For example, we could have incomplete data. Think of a college wanting to predict the factors to successful graduation. If they only get data from the graduates, then their answers could completely miss the factors that cause some of them to drop out. And then, of course, there are human risks. We all have unconscious biases. So you have the developers who are developing the system having their own biases. You have the people who are using the system after it has been developed having their own biases. There could be issues with sampling. Here we might have to talk to statisticians to make sure that the way that we're sampling our populations give us data that is going to be representative. It could be labeling. When you do supervised learning, one of the things you need are records where you know what the conclusion would be. And it takes humans to label all this data. And of course, that brings in the human factor as to how they label that data. Then you could get data that comes from multiple places that you need to aggregate so that you get a sum of information from multiple different sources. Now, it could be that one or more of these sources already had bias introduced, and that would introduce that bias into your own AI system that you're developing. And then, again, to do with humans, you could have confirmation bias, where you start off having a feeling that this should be the result, and therefore you create a model that is likely to create a report that says the result you think it should be is going to be the result that you should use. Once you get a result, there's also the issue of reporting. There could be selective reporting of the results, incorrect interpretation of the result. So even after you've got a model that is very good, the way that you report the results of that model could introduce bias into the operations. Now, we do have regulations in AI governance. One of them is the General Data Protection Regulation. This protects data privacy. It started off in the EU. And there is also the European Union AI Act, and it regulates AI in the EU. Many nations are also in the process of developing guidelines and/or legislation regulating AI. So the key standard organizations that are on the stage are the National Institute of Standards and Technology, NIST, and then we also have ISO and IEC. ISO is the International Organization for Standardization, and IEC is the International Electrotechnical Commission. So let's take a look at the AI lifecycle with AI governance in mind and see how we would manage it. There are several stages that we should take into account. First, there is data ingestion, the point at which we first obtain the data. Then we have data validation, checking on the quality of our data, making sure that it is representative, and so on. Data pre-processing, typically we would do some transformations so that the data is in the right form for our algorithms, actually training the model. Then once we've got the model, we need to analyze what it is producing, validate that it is actually working like it should. Then, of course, we deploy it. Now, after we deploy the model, we're not done. We still need to monitor to see that when it is dealing with real world data, as opposed to our training data, it is actually operating properly. And these lessons learned are fed back into the system development. So it iterates round and round and round, and we try to get better and better and better. So when you look at the initial stage where we acquire the data and prepare the data, what kinds of things do we want to make sure we do? Well, we want to look at the quality of our data, make sure that we comply with privacy regulation. We need to remove inconsistencies, missing values. We need to format the data so that it is uniformly formatted and it is in the format that our algorithm will take. If we're going to do supervised learning, we need to assign accurate labels to the data points that we're going to use. So then we go into developing the model itself. And at that point, we're going to select the data features. These are the predictors. And again, we might need to do some transformations. Sometimes it is things like binning so that, the data that is too fine is now a little more coarse. Or maybe it is changing true false into 0 1s, those kinds of things. We need to choose the appropriate algorithm based on the problem and the data characteristics. And then we need to optimize the model parameters. Usually the first go is going to be, maybe okay, but not as good as it could be. So we might have to do some tuning so that we optimize the model parameters. And then, of course, we need to evaluate the model. We need to know, is it good? Is it good enough? So we have to pick what metrics we're going to use to convince us and other stakeholders that this model is as good as it should be. There are quite a few metrics, things like accuracy, precision, recall, F1 score, and part of the decision-making process as to which one you're going to use is based on your tolerance for risk. Are false positives worse than false negatives? If the false positives are very expensive, then you might go for a different measure from if it is the false negatives that are very expensive. And then, of course, we need to take a look and see if there are biases that we might be able to address immediately in maybe the data or maybe the end product, the model predictions. So now we are in production and we've got our program running. We're not yet done. We need to monitor what it is doing because things could change. For one thing, you're not in the lab. So it could be that we get to a point where we say, well, the data we used has kind of got to a point where it no longer represents the data that we're getting totally. So maybe we need to incorporate some new data, do some retraining of our model. So we continuously monitor our model performance to see if there are any such potential issues and degradation. We could also find that there are changes in the data distribution. Maybe the kinds of customers we're getting have changed, or maybe there are new laws that have come into place. So those might also affect the utility of the model, the accuracy, and it might require updates. We have a term for it, drift detection, where it's not that the model you created was not good, but the environment has changed, and so you have drifted away from the point you want to be at. Now that we've introduced you to AI governance, please join us for more information on AI from Learning Tree International.